Let's talk about the universal language of software architecture, the UML class diagram. It's basically the blueprint that architects and developers use to turn a cool idea into actual working code. But what does it all mean? Let's break it all down.
Have you ever looked at one of these and just felt your eyes glaze over? At first, yeah, it can look like a total mess of boxes and arrows. Kind of intimidating. But I promise you, every single line and every box has a purpose. In the next few minutes, we're going to crack this code together so you can read the story behind the software.
All right, so where do we even begin? Well, every complex structure starts with a single building block, right? In the world of UML, that block is called the class. You can think of it as the master blueprint for any single piece of our system, whether that's a user, a product, or even a transaction.
Visually, a class is just a simple rectangle. That's it. It's divided into 3 compartments, and each of these little sections has a really important job in defining what an object is and what it can do.
In this structure, it's so logical. The top section, that's for the class's name, its identity. The middle part lists its attributes, which is just the data it keeps track of. And the bottom section defines its methods. Those are the actions it can perform. It's a complete profile, what it is, what it knows, and what it can do, all in one little box.
Okay, so now let's zoom in and peek inside that box. The real power of UML comes from the specific way we write down those attributes and methods. This is where the blueprint gets all its important details.
Each attribute follows a really clear format. It starts with a little symbol for visibility, then its name, and finally, its data type. This one simple line tells us 3 crucial things: who can get to this data, what we call it, and what kind of information it's storing.
That first symbol, visibility, is so important for keeping the system secure and stable. A plus sign means it's public, like an open door. Any part of the system can access it. A minus sign makes it private, locked away for internal use only. And the hash symbol, that's for protected access, kind of like a key that you only give to trusted family members. It's all about building strong, secure parts.
Methods follow a pretty similar pattern. You've got the visibility, the name, and then any parameters it needs inside the parentheses. The last part is the return type, which tells us what kind of data the method gives back. And if it doesn't get back anything, if it just does something, like print a file, the return type is simply void. Easy enough, right? So a single class is useful, but the real magic happens when you start connecting them. And the most fundamental relationship they can have is inheritance. Honestly, the best way to think about it is like a family tree. Inheritance is all about building on work you've already done. A child class automatically gets everything its parent has. Think about a general car class. A sports car class, the child, can inherit all the basic car stuff like wheels and engine and just add its own unique thing, like a spoiler. It's super efficient and it just makes sense.
And drawing this relationship is totally straightforward. You start at the child class, draw a solid line up to the parent class, and then you add a hollow arrowhead pointing to the parent. That arrow just shows that the child points to or gets its stuff from the parent.
So far, we've talked about complete, ready-to-go blueprints. But what if you want to create more of a template, like a set of rules or a partial design that other classes have to follow? For that, UML gives us 2 really powerful tools: abstract classes and interfaces.
Okay, and the difference here is critical. An abstract class is an incomplete blueprint. It gives you a foundation that other classes have to build on to become complete. An interface is even more conceptual. It's a pure contract. It doesn't give you any of the building blocks. It just says, hey, if you use me, you must have these specific actions. So how does a regular class officially sign that contract from an interface? It does it through a relationship we call realization. When you see this line on a diagram, it's a promise that the class is going to implement every single method that the interface defined. The visual difference between these two is so subtle, but it's incredibly powerful. Inheritance uses a solid line to show an is-a relationship. A sports car is a car. That's a solid fact. Realization, on the other hand, uses a dotted line for a can-do relationship. A song can be playable. That little line style tells you everything. Solid for identity, dotted for capability. And that's it. That's the core vocabulary for UML class diagrams. You know the class box has our main building block. You've got the visibility symbols for controlling access, you've got the solid line of inheritance for is-a relationships, and the dotted line of realization for can-do capabilities. With just this toolkit, you can now read the fundamental grammar of software design.
So take another look at a diagram like this. It's not just a bunch of random boxes and lines anymore, is it? You can actually see the relationships, the contracts, the family trees. It's a blueprint that's telling a story. And the only question left is, what story does it tell you?